as we get into titrations, it's all about neutralization. So we're either neutralizing a strong acid with a strong base, or a weak acid with a strong base, or a weak base with a strong acid, and so forth. But it's going to boil down to moles. How many moles does it take to neutralize? And the great thing about acids and bases, it's that 1-to-1 ratio. The only time that's different is if you have a diprotic, triprotic acid, then you'll essentially, whatever the moles required to get rid of one, you're just going to multiply it by 2, or 3 if it's triprotic, 2 if it's diprotic. So that will change it. And the only other thing that could come into play is if you're dealing with a strong base that has an OH2 instead, like CdOH2 instead of lithium hydroxide or LiOH or something like that, where there's just one OH. So those are the one place, the couple of places where you may not have a 1-to-1 ratio. But let's look at this. So a lot of times you're gonna have to deal with converting milliliters to liters and solving for moles. So this question asks, how many milliliters of 0.2 molar HCl is required to neutralize 50 milliliters of 0.8 molar NaOH? So NaOH is what we have, say, in the beaker. HCl is what we're adding through the burette. So let's figure out how many moles of NaOH we have. So we're going to say 0.80 molar is moles per liter. I need to get rid of liters. I'm going to convert 50 milliliters, 1,000 milliliters per 1 liter. So I'm going to get 0.0500 liters. So I'm going to multiply that. So 0.8 times 0.05, and I get 0.04, 0.04 moles of OH minus. And so I need 0.0400 moles of H plus to neutralize it. And HCl forms H plus, 100% ionization. So we need 0.04 moles per liter of HCl. We know our molarity is 0.2, so we need to figure out how many milliliters we need. So I need to get out of moles into liters, so I'm going to multiply this number by 0.2 moles per liter. No, notice this is back to when we learned about dimensional analysis. We can flip these units over, right? So there's, for every 1 liter of HCl, there's 0.20 moles. This is going to cancel moles. So 0.04 divided by 0.2 will tell me how many liters. So that's 0.200 liters. Now I'm going to multiply that by 1,000, and I get 200 milliliters. Notice it asks for milliliters, so I got to solve for milliliters. So does that make sense? I have 0.8 molar NaOH, 50 milliliters. I have 0.2 molar HCl, so I need 4 times as much because it's a fourth. You could also do like a M1V1 and M2V2 type of calculation if you wanted, but I like solving for moles because it's all about the moles in titration. So this gives us a good idea of how it works. It would be the same calculation if I was looking for the equivalence point. Equivalence point is when you've canceled out all the moles. So let's look, 200 milliliters. There we go. 2 sig figs would be 2 times 10 to the second. So here we go.